Hello everyone, for this video we're going to talk about equation of a circle. And for this video, what is our learning target? Now I can determine the equation of a circle in center radius form and in general form. Now hopefully after watching this video, you will be able to answer the following guide questions. Now first, what are the steps in finding the equation of a circle? So here we do have 4 steps, and the first one we have find the coordinates of the center. Second, find the length of its radius. Third, we have substitute the values to the equation. So actually for our step 3, this is the start of creating your center radius form. And for our fourth step, this is the time wherein you are going to have your general form. Now, what is center radius form? So this is also known as standard form. So let's say the equation of a circle centered at HK having radius of length R. So this will be your format. So quantity x minus h squared added with quantity y minus k squared, it is equal with r squared. And for the general form, so this will be the format as well. So x squared plus y squared plus dx plus ey plus f equals 0. So a while ago in our steps, for our fourth step, you just simply simplify to get the general form. So aside from simplifying, actually in simplifying guys, you are supposed to apply your previous knowledge on FOIL method or distributive property, and so you will be able to come up with your general form. But here I do have here the formula as well, so you just simply look at the pattern given x squared plus y squared, and to find the numerical coefficients of d and e, you may use this formula. This is the shortcut. And at the same time, to get the value of f or your constant, so you may use as well this formula. You just simply square the h added with square of k and then deducted by the square of r. And then don't forget, if it's in general form, you equate this to 0 always. Now, let us have our seat work or practice exercise so that you will be able to understand thoroughly our topic for this video. So for our first practice, so write the standard form and general form of the equation of a circle with the following conditions. So centered at the origin with radius 5. So let's do this one by one. So let's have our first step. So find the coordinates of the center. So here, as mentioned, centered at the origin. But a while ago, if you can still remember, we represent the coordinates of the center using our variable hk, wherein h is our x coordinate and k is our y coordinate. So now, as mentioned in here in our problem, centered at the origin. So what is the coordinate of our origin? So we have 0, 0. And with that, we can specify, to make it more specific, let us have h equals, so what is our x coordinate? So 0. And for our k or the y coordinate, we do have 0. So you may specify this way so that it would be easier for you to substitute later on. Okay, next, find the length of its radius. So luckily, it's given already. Radius is equal to 5. Okay, for our step number 3, so substitute the values to the equation. So here we do have our format already for the center radius form. So you just simply substitute all the values that we've got for h, k, and r. So we have here, simply copy the x minus, and then what is the value of h again? So it's 0. So we have here 0 squared, and then copy y again, and then what is the value of k? We have 0 as well. And then what is the value of r? We do have 5. Okay, next to that, of course, this is not yet our final answer because as you can see, we do have here x minus 0 and it should be simplified. So what is x minus 0? It is x, and then don't forget the square, and then y minus 0, it's y, and don't forget as well the squared. And lastly, we do have 5 squared. What is 5 times 5? So we have 25. And therefore, our final answer for center radius form is this one. So as easy as this. So next is, let's proceed with our step number 4. So for our step number 4, to get the general form, you may use simplifying. So how are you going to simplify? You just simply expand our center radius form, but luckily since we do have x squared plus y squared equals 25, you just simply do x squared plus y squared and then transfer positive 25, the constant, to the left side, negative 25, and then equate to 0, and you're done. So this will be your general form already. Okay, so if you are not that convinced for now, so you may use the formula I presented a while ago. You find the value of the coefficients for D and E, and then for the constant F. So you may rewrite here the x squared plus y squared plus dx plus ey plus f equals 0. So you may start with checking D is equal to, our formula a while ago is negative 2h. So now you may substitute to check. So we have negative 2 times, what's the value of our h? It's a 0. So negative 2 times 0, it's a 0. Next, to find our e, our formula as well is negative 2 but multiplied with k. So we may substitute now negative 2, and what is the value of our k? 0 as well. So negative 2 times 0, it's 0. And lastly, for our f, our formula is h squared plus k squared minus r squared. So if we're going to substitute, so we have our 0 for h, so 0 squared, plus 0 squared again for k, minus our r is 5, so 5 squared. So simplified further, we would have 0 squared plus 0 squared, so it would be 0, and then 5 squared, it would be 25, so that would be 0 minus 25, or so we would have our f equals negative 25. And with that, you may now substitute all the values that we've got for D, E, and then for our f here in the format of our general form. But as you can see here, so it's fixed x squared plus y squared, and since numerical coefficient for D we got 0, so 0x, so it's not necessary anymore, so you may remove that one. So may remove this. And for E, so since we got 0 as well, so we may eliminate that term. And for our f, we got negative 25, and with that we have here, so x squared plus y squared minus 25, and just simply equate to 0, and we're done. So we got same answer. If you are going to use the formula or the simplifying itself. For our next problem, we do have centered at 2, 4 with radius r. So we have, first step, find the coordinates of the center. So it's already given, we do have 2, 4, but let us specify what is our h, so which is 2, and what is our k, which is 4. Okay, now So next step, find the length of the radius. So radius is equal to 3. Next step is substitute the values to the equation. So of course we are going to substitute all the values that we've got, the h, the k, and then the r. So we have here x minus, and what is the value of h? We have 2. So by the way here guys, if in case we got the value of h or LCK which is negative, so it has something to do with the format here. Like for example we have x minus, and then the value of h is negative 2. Let's say, and this is just an example. So we have here x minus negative 2. If that's the case, you should simplify this. And we all know we can have here keep plus change. So with that, so we would have x plus 2 instead. This happens if the value of our h or our k is in negative sign or negative form. So it changes the pattern of our center radius form. Okay, by the way, let's go back with the original data that is given. So we have here, now moving on to our next square of binomial. So we have y minus, and since our value of k is simply positive, so you just write it positive 4, and then square, and then our radius is 3, and here we go, so 3 squared. Now this is not yet the final answer because we need to simplify those things that we really need to simplify yet. So we have here at the left side, we are not going to change anymore here all the binomials here that we have, so just simply rewrite it. But we need to simplify the r here. So r squared, that is, wherein we do have r is 3, so we have 9. And therefore, this would be our final answer. This is our center radius form. Okay, so moving on for our step number 4. So we just simply copy our or rewrite our general form so that you will be guided of all the things that you're going to do. So here I'm gonna use the formula that I presented to you a while ago, the DEF. So let us simply substitute. So here we do have our h and k already, so we may have the solution. So negative 2 times our h is 2, so negative 2 times 2, we would have positive negative 4, I mean. So we have negative 4. Next is for our e. So negative 2 times k is 4, so negative 2 times 4, we would have negative 8. Okay, next is for our f. So let us substitute first. So h is 2, so 2 squared, plus k is 4, so 4 squared, minus our r is 3, so 3 squared. So simplify further, we would have 2 squared is 4, 4 squared is 16, negative 3 squared I mean is 9, so negative 9. So you just combine, you will have 20, 4 plus 16 is 20, minus 9, so you would have positive 11 for f. And after that, you just simply substitute here in our general form given. So our final answer would be, so it's fixed, we would have x squared plus y squared. And then for our dx, our numerical coefficient, for d, we have negative 4, so negative 4x. And for our e, we got negative 8, so negative 8y. And for our f, we got positive 11, so plus 11. And you just simply equate it to 0. And you're done. So this would be your general form. By the way, don't forget, as you can see, the format in general form, we do have our variables in alternate form, so x, y, xy. So mostly you got wrong for this. So x squared plus y squared, and then another variable is x, another variable is y. Don't forget to attach the specific variables to your d, to your e. And of course for f, that is your constant already. Okay, so for those who are asking, how about those topic, the steps using simplifying or the expansion? For you to get the general form, you may also use this method. You may expand x minus 2 multiplied with x minus 2. So you will get x squared minus 4x plus 4. And you expand as well y minus 4 times y minus 4. So you would have y squared minus 8y plus 16. Then after that, you combine like terms together with this constant 9, and you will be able to get the same answer as this. So x squared plus y squared minus 4x minus 8y plus 11 equals 0. And that's it. Next is for our next problem with diameter whose endpoints are negative 2, 3, and 4, 5. So a while ago, if you can still remember the necessary data that we really need in our center radius form and general form, basically we're going to start with having our coordinates of the center and the length of the radius. But as you can see here, we don't have the coordinates for the center directly given, so we need to apply some of the concepts that would help us to find the coordinates of the center. So luckily we do have our data about diameter, the endpoints of the diameter, and we all know if we're going to get the midpoint of our diameter, then we can have it also as the center of the circle. So therefore, we may apply for our step 1 to get the coordinates of the midpoint of the diameter or the center of the circle. So we may have the midpoint formula. So let us use the coordinates of the endpoints of our diameter, which is given. So take note or recall the formula to find the coordinates of the midpoint. So here, so x sub 1 plus x sub 2 all over 2, and then to get the y coordinate, so y sub 1 plus y sub 2 divided by 2. So of course, let us substitute. So I've given you some tip before that it's better if you determine where is your x sub 1, y sub 1, x sub 2, and y sub 2, so that it would be easier for you to substitute and to avoid confusion. So let us now substitute. So here I have the x sub 1, which is negative 2, x sub 2 is 4, and y sub 1 is 3, y sub 2 is 5. So combine necessary values. So we do have positive 2 divided by 2 and positive 8 divided by 2. Simplify further, we would have 1, 4. And with that, this is the coordinate of our midpoint or center of the circle, and therefore we can say that our h is 1, our k is positive 4. Next, let's proceed with finding the length of our radius. So it's not directly given as well. So in this process, we need to use the idea on distance formula, guys. So I'm gonna use here, in this case, I'm gonna use the coordinates of our center that we've got a while ago, 1, 4, and one of the endpoints of our diameter, so that starting from the center up to that endpoint, we would have our radius already. So, but if you wanted to compute for the distance of the entire diameter and just simply divide it by 2, so it is still the same. So it's your choice if what process are you going to do, because we all know half of a diameter is equal to a radius as well. But here I'm gonna use directly the center point and one of the endpoints of our diameter to get the radius already. So here 1, 4, and I chose a 4, 5, so the positive coordinate, so that it would be easier for me to simplify later on. So x sub 1, y sub 1, and then x sub 2, and then y sub 2. And then, of course, let's substitute already all the values here. And then simplify. 4 minus 1, we do have 3 squared. Plus 5 minus 4, we do have 1, which is, we have here 1 squared. And simplify further. 3 squared is 9. 1 squared is 1. And lastly, 9 plus 1, we do have 10. So it's not necessary for you anymore to convert it to decimal or whatsoever. So this is your final answer. Just square root of 10. It's okay already. Okay, so for step number 3, let's start with our center radius form already. But of course, what are the things that we need to have? So our basic informations that we got already, which are h, k, and then value of our r, okay, or the length of our radius, I mean. So substitute it here. So we would have, so our h here is positive 1, so you just simply substitute it here, positive 1. And for k, we have positive 4, so we have here positive 4. And then for our r, we do have square root of 10, so we have here square root of 10. And then simplify if necessary. So here we would have, so you will not change anything here at the left side anymore. So you just simply simplify square root of 10 squared. So that is 10. And therefore, this is your center radius form already. Next is for our last step. So you proceed with getting the general form already. So to get that, of course, we are going to rely as well with h, k, and our r. So I'm gonna use here the formula for DEF instead of the FOIL method, the expansion, and whatsoever. So here, so we all know we do have the fixed terms for our general form, x squared and y squared. So to get the next term, so you just simply use the formula for DEF to get the coefficient. So we have for D, it's negative 2 times h, and our h is 1, so negative 2 times 1, so negative 2. And then attach the variable x. Next is to get the e, so you just simply use the formula negative 2 times the k, so negative 2 times 4, so we would have negative 8y. And next is to find our constant. You just simply square the h, square the k as well, and then deducted by the square of our r, and with that we would have positive 7, and you just simply equate it to 0 and you're done. So this would be our final answer for the general form. Okay, so next is, okay, so last one, we have tangent to x-axis with center located at 4, -6. So let's start with our first step. So the coordinates of the center is already given. So we have 4, -6. And of course, we do have our h is 4. And for our k, we do have -6. Now, for our step number 2, find the length of its radius. As you can see, the length of the radius is not directly given, but rather we do have here tangent to x-axis. So I'm gonna give you the shortcut already. So if this is the condition, tangent to the x-axis, you just simply look at the y-coordinate of your center, and that is -6. But of course, since we're talking about length of the radius, so we should or we must consider the absolute value of this -6. So what is the absolute value of that? So of course, it would be positive 6. So again, if the scenario given is tangent to the x-axis, you just look at the y-coordinate of your center. But if the scenario is tangent to the y-axis, then you are supposed to look at the x-coordinate of your center. And that would give you the clue for the length of the radius. Okay, so next is substitute the values to the equation of our center radius. So we have here, and then after that, of course, we are going to substitute our values for h, k, and for our r. So we have here, as you can see, for our h, we have positive 4. So we have here x minus positive 4. And then for our y, so we have y minus. And since our k is negative 6, so y minus negative 6, so you need to simplify that and you would have y plus 6 already. Okay, and then substitute again for r, which is 6, then 6 squared, and then simplify. So here at the left side of your equation, you're not going to change anymore whatever binomials here we have. Just focus with your right side. So 6 squared, that would be 36. So this would be your center radius form already. And your general form, so you may use again the format of your general form and the formula I've given to you a while ago, the DEF. So the shortcut, so let's start with our D. So negative 2 times the value of our h, which is 4. So 2 times 4, so we would have, negative 2, so times 4, we have negative 8. Next is negative 2 times negative 6, so we would have positive 12. And to find the constant, so get the squares of the following. So simply substitute first. So 4 squared plus negative 6 squared minus 6 squared. So with that, simplify further. 16 plus 36 minus 36, then we would have 16. And lastly, of course, let's substitute all the values that we've got for DEF in our general form. So we would have x squared plus y squared minus 8x plus 12y plus 16 equals 0. Okay, so that's all for this video. Thank you so much for watching. I do hope you learn about determining the center radius form and then the general form of the equation of a circle. Thank you so much.